So this is 7.2 beta. Same problem in the book. Just the gray, it looks a little better in the book because they have it, the areas in two different colors. There's the dx. So dx is upper, take away lower. So what happens? And this is, like I told you, this is sloppy in the book because they should have written what I wrote on the PDF. It's root x subtract 0, which isn't going to affect anything, but it makes it more consistent. It's upper, take away lower. So it's root x take away 0 from 0 to 2. Why 2? Because when x is 2, then this height is 0, and that's where the lower bound is changing. 2 to 4, upper, take away lower. Now, this is what's new. Well, suppose we did the problem dy. We wouldn't need two separate regions. Because if you drew your strip, this way, dy, then right take away left, the entire time would be the same measurement. And you'd only have to do one integral. Yeah, but that kind of fouls me up. You don't have a choice. Because some of the questions are going to force you that. It's like this. You want to be on the basketball team? Would that be nice? Yeah, it would be now, because now the basketball team's starting to win. It's had some getting lumped up for a few years, and now we're winning. Except what? If you want to be on the basketball team, you have to be able to get the ball over half court with your right hand, your left hand. If you're in gym class and you're the best player in gym and you can't dribble with your left hand, you're delusional if you think you could be on the team. Oh, you should see me shoot. Okay. Ready? You have to be able to get over the court, over half court with your offhand. Or, ready? Thanks for coming out. That's what you would get. And in this case, you might say, well, my strong way to do this is dx. You still have to be able to do problems dy if you're going to succeed on the test. And you're going to see why when I show you the problem on the PDF from the end. Sometimes College Board will force you to do the problem dy. So you have to conceptualize what this is about. Okay? So this is a really helpful screen because you can see the difference. dx is the sum of two separate integrals. dy is just one integral. But how would you set it up? Well, there's the one curve, y equals root x. But if I'm going to do the problem dy, I got to solve it for x. So if you want to do the problem dy, now think about this. Suppose I have something that you used to sing. Oh, I don't know. What's the integral of y equals 2x? I want to integrate that. Yes. dx. Because what? X is your input and dx is your width. If you're doing the problem dy, then it has to be x equals, because y has to be your input. Now, that's just algebra 1. Rewriting this is this and that is that. It's not complicated. So now what? Right take away left. This line is y plus 2. The curve is y squared. Right take away left. New limits. The limits have to be in terms of y. So we're going from 0, and where do these curves meet? They meet here at the point 4, 2. Where does root x equal x take away 2? So we did this yesterday, but you weren't here to see it at home. We square both sides, and we get x equals x squared. I give you a lattice for this, but x squared plus a negative 4x plus 4, which is x squared plus a negative 5x plus 4 equals 0. So now I use the lattice and say, where do they meet? X squared and 4, they're both negative. Negative 4, negative 1. Gives me negative 4x and a negative x, which is negative 5x. So they meet at 1 and 4. We go with that? But they meet at 1. When you go 1 to the right, they're meeting in quadrant 4, which we don't want. Why? Because I took root x and I squared it, which would be the same thing as if I took negative root x and I squared it, the opposite of root x and I squared it. So it gave me more information than I needed. So I need the 4. So I say 4 does what? Well, I go to either one. Root 4 is 2. 4 take away 2 is 2. This is the ordered pair. So when I do this, dx, back up, the limits dx are 0 to 2 and 2 to 4. 0 to 2, 2 to 4, horizontally. The limits dy are 0 to 2, vertically. So you have to rewrite the curves in what x equals, and you have to rewrite the limits. But now you don't have to do one integral. So we get this. Looking at that, power rule in reverse. Is that complicated? No. It was the first day you saw it, maybe the first 2 days. Same answers yesterday, 10/3, but you only needed one integral. Yeah, I'm not sure this is helpful, but general strategy. Well, decide whether you're going vertically or horizontal. Vertically is dy, horizontal is dx. Okay? If the width is dx, the length must be in terms of x. The other way around. The limits. If you're using dx, the limits are x values. If you're using dy, they're y values. We'll come back to this question. So here we are. I wrote it as 26 instead of 10/3, the same thing. I didn't reduce it because I just left the common denominator in the problem. If you don't reduce a fraction on May 4th, it's all good. Your answer is exact. I mean, your answer is the same. What if you leave a unsimplified root sign? What if you write root 8? Oh, yes, it's fine. 2 root 2 equals root 8. Ready? That's algebra 1.5. We're trying to learn calculus. I'm not really worried about simplifying radicals or fractions. Kidding me? So I'll leave that up there. That's the example. You go to problem number 9. Is that the problem we did yesterday? It is? So you're going to go to the same problem we did yesterday, but you're going to do the problem dy. So you're going to get the same answer if you do it correctly. Problem 9. We have this. There's a little more to it than the other example. Y equals x, so x equals y. Now I have x squared equals 4y. So what does x equal? Root 4y. But if I'm going to anti-differentiate that, ready? D mu dy is 4, and d mu is 4 dy. So when you anti-differentiate this, you're going to need to do substitution. So you would have this. Right take away left. Right take away left from 0 to 1. The sum of the integrals, or I'm sorry, the integral of a sum is the sum of the integrals. So I can write this as two separate integrals because I only need the substitution on the left one. So to anti-differentiate this mu to the 1/2, I need 4 dy, so I put the 1/4 out front. Okay? And then here's the work that takes you to 5/6. That was one way to, and the limits are 0 to 1. That was one way to do it. You didn't have to, because you could have done it this way. You could have said, well, 4y to the 1/2 power, the product of the 1/2 power, is 2y to the 1/2. So if you did it that way, it's going to take you to the same place. So the bottom way is more efficient, but if you did, if that wasn't something that was a perfect square, you would have to do it the top way. Okay? So, couple things. We're here till 24, and I want to go over the problem at the top, which is this. They're not asking you to do it. They're just asking you to set it up. But you have to know what the limits are. So here's the question. R is the region in quadrant 1 bounded by the x-axis. X equals y squared plus 2, and x equals 4. Do you understand what's happening? This problem is, they're already giving it to you in x equals. So the problem's a dy problem. But there's only one of those is the correct way to do it. So what does that mean? It's a non-calculator question which gives you 2 minutes to do it. Begin. Non-calculator questions. You need to build a T-chart so you can sketch this graph freehand to see what this looks like. Because you got to do right, take away left. So I'm in the first quadrant. Here's x equals 4. Where's the curve? You only need a couple little pairs between 0 and 4. So, anybody? Okay. What have you got? Well, here's the long way. But what answer doesn't make sense? Tell me what answers there can't be right. C and D, why not? It says first quadrant, right? It says first quadrant, so you can't have any negative values in there. So C and D are out. And there's 5 choices, but in May you don't have to have 4 choices. So if you can eliminate 2 of them, even if you're guessing, your expected outcome goes up. Yes? So here's what it looks like. I drew a kind of freehand over there. But you're doing right, take away, left. Okay? Now, here's the thing I just want you to stay away from. This is a middle school strategy. Oh, well, these are the same, and they happen 3 times, and they're the same, it only happens twice. It's got to be one of those 3. That is so transparently shallow and incorrect. Don't do it. It might have worked for your 4th grade teacher at St. Kevin's, who really wasn't good at making up multiple choice questions, but a valid and reliable test will not, you won't be able to get away with that. Okay? So if you're at home, you're dismissed to do the exit ticket. Okay? Now, I know I'm letting you go a little late, but the exit ticket will be open until 10:30, and you don't have to be in 4th period till 10:32, so you're good. If you are here, let's go to problem 11. Now, I'm not worried about an answer. Let's just set 11 up. And we're going to run out of time, but I'm telling you this. 11 is on the PDF. So the solution's there as you're going over this, and you look at the homework problems to do, take a look at 11 and compare it to what's on the PDF and see if that makes sense to you. All right? So have a nice 2-day weekend. And we're looking forward to seeing you in the building on Tuesday.